We have 4 to the power of I and I to the power of 4. I is an imaginary number. Which one is bigger? Let's start with I to the power of 4. It's easier to calculate. I to the 4th is the square of I squared. I squared equals minus 1, so I to the 4th is the square of minus 1. It's 1. Now it's time to calculate 4 to the power of I. To get a better sense of this number, rewrite 4 in a different form. Using logarithms, we know that x equals e to the power of natural log of x. What's a natural log? It's a log with base e, the natural constant. So x equals e to the power of natural log of x. Applying this to 4, we get 4 equals e to the power of ln 4. Therefore, 4 to the power of I equals this. Using the laws of exponents, this becomes e to the power of I ln 4. Let's substitute ln 4 with theta. What's this number? Using Euler's formula, it can be expressed as a complex number with an absolute value of 1 and an argument of theta. Now, plug ln 4 back in theta. So 4 to the power of I becomes cosine ln 4 plus I sine ln 4. Here, ln 4 is approximately 1.386. The unit is radians. When converted to degrees, it is approximately 79.4 degrees. Therefore, 4 to the power of I becomes this. Substitute the values of sine and cosine. Thus, 4 to the power of I is approximately 0.188 plus 0.982i. Let's return to the original question. On the complex plane, 4 to the power of I is represented here. I to the power of 4 is represented here. Which one is bigger? Can we compare the magnitudes of a real number and a complex number? To answer this question, we should be able to define the magnitude of the imaginary unit I. Let's check if I is positive or negative. Imaginary I satisfies I squared equals minus 1, so I is not 0, because if I were 0, then I squared would also be 0. Let's assume I is greater than 0. If we multiply both sides by I, the inequality stays the same, but the left-hand side becomes I squared, which is minus 1, while the right-hand side is 0. This implies that minus 1 is greater than 0, which is a contradiction, so I is greater than 0 is incorrect. Now assume I is less than 0. Multiply both sides by I, and the inequality flips. The left-hand side becomes I squared, which is minus 1, and while the right-hand side is 0. Minus 1 is greater than 0. This is also a contradiction. In conclusion, I is neither greater than 0, less than 0, nor equal to 0. As a result, we can't compare the sizes of a real number and a complex number. This is because complex numbers do not have a linear order like real numbers. However, we can compare the absolute values of complex numbers. The absolute value of 4 to the power of I is 1, and the absolute value of I to the power of 4 is 1. Their absolute values are equal. 4 to the power of I is a complex number, and I to the power of 4 is a real number. Therefore, they can't be directly compared in size. They are just different.